This video is going to be looking at these different sensors. So if you look here, we have a force sensor, and we're just plugging it into a multimeter, and we have the resistance set on it. This is a flux sensor, and we also are measuring resistance on it. This is a photoresistor, and we are also measuring resistance, and the same for the light sensor. It's actually called an ambient light sensor, but you get the idea. This other one at the bottom, and I've got 3 different versions of it because it's a diode, and I'll see if I can show you that picture. So if you look at a resistor or a potentiometer, we have this squiggly line, and the electrons that are moving through it, or the currents moving through it, or the voltage, however you want to think of it, is going through, and it could go through either direction. But when you look at the diode is got a directional thing. So we've got an anode, which is the positive, and a cathode, which is the negative, and it only flows one way. And so that's the difference in this setup. So when you're playing around with this, and I'll hit simulate right now, you'll see that for the force sensor, I can move the slider, and it changes from basically as little as 1.2 kilo ohms all the way up to a mega. Okay, so it's got a huge difference. This one is a flex sensor, and you can bend it, and it's got kind of a larger range. This is the photoresistor, and it's got a dial, so you can play with. This would be brighter, it would have less resistance, and when it's darker, it would have more resistance. This is a light sensor, so it acts very similar. So in the dark, it has a lot of resistance, and in the light, it has very little resistance. Okay, so now this is where it gets a little weirder. For this one, it's a diode, so it can only go in one direction, and in this particular case we have it hooked up to 9 volts, so we can, when it's dark, it's still going to allow 8.91 volts to go through it, and when it's in bright condition, it's going to be just a slight difference. Now with a microcontroller, we can sense the difference in that. Now you'll note down here that if we hook it up in one direction, we have 1,000 Ks of resistance in the dark, and then in the light it goes down to about 10 Ks. So there's a huge difference between a light condition where there's very little resistance and a dark condition where there's a lot of resistance. Now on this one here, we have it kind of hooked up. If you look, it's kind of positive to positive, negative to negative. And in this case, it doesn't really change that much. I have it set up the wrong thing. So when I have it hooked on resistance, it doesn't change at all. When I have it on voltage, it's going to act as a little bit of a solar panel. So it's going to have a little bit of voltage change depending whether it's dark or not. So in the dark, it would be 0 volts, and in the light, it would be just almost half a volt. So that's because it's kind of like a solar panel. So your task is to duplicate all of these. If you want to play with using a battery in series and see how that affects the voltage, you can. But the primary goal here is just to realize that a lot of times they're going to act as the potentiometer that we looked at last lesson. Okay, so it's just a matter of changing the resistance, and they're going to do it in each different way. So this you could think of as a scale. This you could maybe think of on a robot finger to tell how much flexion there would be in the finger. This is often to sense whether it's in a lighted situation or a dark situation. I have one of those on in my garage so that when it's dark, there's kind of a night light that goes on so that I can access a plug-in. This one is a light sensor, so it would be very similar. I'm not sure of when you would use one versus the other. They're kind of the same to me. And then this diode is going to be similar to these other two up here. Okay, so good luck doing that and have fun.